Hey everybody, I'm Alex with PotentialU Education, and here we're going to walk through networks. I'm here with Ali, our founder.
Hi everyone.
And he's going to be asking some questions. So yeah, let's get right into it. Welcome to networks. What is a network? So a network is two or more computers or general electronic devices that are connected together in order to communicate. So how many different types of networks are there? There are three different types of networks, LANs, WANs, and PANs. So what is an LAN? An LAN or a LAN is a local area network. So this means it's geographically confined to a single building or potentially even a campus, like a university campus, most likely your school or your home, usually very small geographical areas, and they're maintained by the organization that they belong to.
So Alex, why, for example, you mentioned a school or someone's home, why would they use an LAN?
So an LAN is quite handy for smaller organizations, especially in size, because you don't have the large costs of having a main server room. You don't have the large costs of maintaining and hiring people to fix it. Another good reason is for file sharing. So you can quite easily share files between computers in a home, which is usually a trusted network. You can share hardware as well. So your printer, you don't want everybody to have to buy their own printer in your house. You've probably got one printer that everybody shares. So it's just good for keeping everything nice and like closely knit. So what is a WAN? So a WAN, which is a wide area network. So there's a network over a wide geographical area. So it can cover more than one site, a country, or it could technically be the entire world. So companies have many different offices and they're likely to have WANs in them. So Barclays has probably got one between all the different offices in the UK, and they likely have one that's even larger across different countries. All their different offices will have these connected, and this is done through the phone line. So it is quite expensive to set up because you've got to make a contract with the phone company, usually BT. You can do it wirelessly though nowadays. That's much more common and cheaper. So each office will have its own LAN, and then these will be connected by a WAN. So it's smaller networks within a bigger network. And then we've got PANs as well, which are personal area networks. That's a network that is spread over an incredibly small area, used to connect personal devices, so your AirPods or your laptop, also how you create a hotspot for your phone. That's as complicated as it gets. So what are the different types of networks? There's wireless and then there's wired. So wired networks use physical wiring to connect devices. They're mostly used in offices and for devices that won't move. You wouldn't want a wired network for your mobile phone because you'd never be able to walk out of the house with it. It would simply lose connection. And wireless networks use radio waves to carry signals. These are usually about a range of 50 meters, but it can be blocked by walls. So if you have a steel bar in your walls, you can create tempest-proof rooms, which means rooms that have no internet in them whatsoever. This is typically done for companies using a lot of proprietary software that they don't want stolen. I know, for instance, BlackBerry has tempest-proof rooms. That way people can't steal their information upon new phones that they're making. I know that the government also has them for MI5 and all those sorts of spy organizations. And that way you can't be listened in on from the outside wirelessly. So wired networks are very expensive to install, and it requires a lot of technical knowledge and definitely a lot of space and planning to see where the wires are going to go. And you've got to get somebody to physically put them in, all of these different wires, which are heavy and expensive. However, they are incredibly fast. So it's up to a gigabit per second for Ethernet. You could download games like Fortnite in a few minutes. It's really, really quick. And the maximum reliable distance is up to 100 meters. For just Ethernet, which is coaxial cable, so that's a copper cable. However, 2 kilometers for fiber optic, which is lights going down bendy pieces of glass, to put it simply. And those will run under the sea, and that's how we connect to other countries like America or even France through these giant, well, internet backbones, which are just big collections of cables. So they're more secure as a physical connection is required to intercept data. If somebody wanted to steal your data and the only access point was an undersea cable, it will become incredibly difficult for them to do it without diving all the way down there to the sea floor and opening up the cable and quite possibly destroying the entire internet in the process. So stuff like that, it's difficult to do. I mean, if it's like a wired connection in an office, probably a bit easier. No diving equipment required, but yeah. And wireless networks, they're cheap. Devices can connect super easily. Installation is really simple. Just have the guy from Virgin Media go around and he'll sort it for maybe 30 minutes. It's 50 megabits per second. It is getting faster, and it's also up to 50 meters. However, as I've previously mentioned, walls are not your friend. So it's less secure as the wireless signal can't be contained within a building, and luckily no physical connection is needed to steal data. If you're a hacker, you don't have to connect directly to the Wi-Fi box. You can just sit on Starbucks public Wi-Fi and see what everybody's up to.
So what are there any other kind of things that could affect the range of a wireless network?
Yeah, so any sort of metal is really really awful for wireless networks. Bricks, anything really thick. Your best bet to get a good wireless connection is to have absolutely nothing in between you, because it's radio waves, so they can bounce off and they won't pierce through the materials completely. So yeah, probably the worst thing to do is surround yourself in a lead box. I don't think you'd be getting any signal in that. So LAN hardware. So NIC, which is network interface cards. So these offer an interface support for a wired connection, and a wireless NIC. You can guess what that does. And you need one of these when you're building your own computer, because otherwise you won't be able to connect to the internet. You won't have the correct ports to do it. So switches, they sit in the middle of the network and they direct traffic. Routers send data and signals, and then they analyze the best route to send the data. You might believe that you could do it yourself by just looking at how far the distance is. However, there's all sorts of algorithms for it. Dijkstra's algorithm, A-star algorithm, just to check the distances between 2 points and whether one's very congested. For instance, if you were driving from Edinburgh to Manchester, it might look like, oh, this is just one road that I take. However, if there's lots of traffic on that road, then maybe you're better off going around a different way to get there. And then modems, which allow computers to connect to the network over a telephone line, and those are quite old-fashioned.
Yeah, they are quite old-fashioned, aren't they? So in fact, I was going to ask, which one would you say is most common to find? I assume it'd be the routers, right?
Yes, so routers, pretty much every home is going to have a router. Very confusingly, if you've got a Wi-Fi box, it's most likely called a router. However, it isn't. It's got a router in it, absolutely, but it also has much more hardware than that. So when somebody says, oh, here's the router, I suppose technically it's in there, but it's also like pointing to a remote and saying, oh, here are the batteries. So yeah, there's more to it than that. But use of physical wiring can be expensive, so it's definitely worth knowing the costs. So twisted copper wire, it's cheaper to purchase and install, but anybody that's got copper piping in their house will know that copper is not cheap. It's quite an expensive material, and it's got a max transmission of 10 gigabits a second. The distance for reliable communication is about 100 meters, and fiber optic, it's way more expensive. way faster and a much higher distance, so you get much more for your money. However, it's a significant investment. And then we've got wireless access points, or WAP. So uses a radio transceiver to allow wireless connection to a network. In effect, the WAP creates its own wireless network, which devices connect to, and then it sends out the wireless traffic it receives onto the main wired network. So with this, what you might be able to do with them in order to extend your range is put one WAP next to another WAP and then have all these WAPs in a row. But yeah, you can daisy chain and create a much longer connection. So yeah. So what are the advantages of using networks? So file sharing, hardware sharing, communication, user monitoring. Usually in a school, your teachers will be able to see what you're up to on your computers, levels of access as well. A kid isn't going to be able to take the register and send it off to the front desk. Roaming access, so you can connect to multiple different networks. If you're at your friend's house, you can just join their network, and then, oh, I need to borrow your printer, you can just do it. Centralized maintenance and updates, especially if you've got a main server, then you can have the main server, which might have 10 copies of Windows on it, and then everywhere else you've just got what we call terminals. So that would be a screen, a keyboard, and a mouse, most likely. And then that way you don't even have to run your own version of the operating system. You just call to the server to pull it for you, and it's much faster that way. Instead of everybody being on different versions, you're all on the same one. And also centralized security. So one simple update will update all of the security in a network, rather than everybody having to set aside a specific time for, we all need to update at this time. You can have the server update late at night when nobody's likely to be using it. There are disadvantages though, however. So the cost of networks, you've got to get a server, you've got to get some wires, you've got to pay the man from Virgin Media to come round. It can get expensive. It's probably worth it if you want to connect to the internet. Most devices are pretty useless if they're not. And there's also the issue of managing it. You've got to pay somebody as a data center employee, or somebody to look at the cables when they're broken, someone to make sure that the server isn't down, and hacking especially. You've got what's called a single point of failure. So if your server breaks, then everything's broken. Whereas if you weren't to have a network, then it's unlikely that just one thing breaking will completely destroy your whole business, for instance. And then hacking and the spread of malware as well. If you've just got one access point, while yes, it's great because you can share all of your files, that means that if somebody hacks into it, they can also access every single computer and all of the files all at once. So it's not as secure. And the spread of malware is also a lot higher risk, as once it infects the server, it can just infect every computer connected.
Are there any other security risks that come with it?
I'd say that the hacking and the spread of malware are the main ones. Another issue is man-in-the-middle attacks. If you're on a network, somebody can listen in to what you're sending to the server, or even to the internet potentially. And that can be quite a risk, especially for hackers. Usually, if you're on a home Wi-Fi network, I doubt that your parents are spying on you as to how they would like see what you're looking at. I mean, I don't even know how you'd be able to do that. So unless somebody's got some really tech savvy parents, then maybe. But yeah, most normal users aren't going to be spying on each other on a network. That is a danger of public Wi-Fi though. If you go into a cafe or something, or a business, and you use public Wi-Fi, no security on it, no logins, no nothing, it's highly likely that people there are just gathering your data as you're using the Wi-Fi. And that can be stuff like your passwords, your username, your credit card information, anything that you choose to do on public Wi-Fi. You should consider as advertising to the entire world. So if you're on public Wi-Fi and you're going to make a purchase online, it's best to think about that as shouting your credit card number and the 3 digits on the back to everybody in that room, because they may as well see it already. So if you want to do something like that, just switch to mobile data, much more secure. They're not going to be able to get into that. So yeah, here you go, Ali. Multiple choice question. Which of the following, I think I've already ruined it. Anyway, which of the following is the primary function of a router in a computer?
B.
B, to connect multiple devices within a local area network. Unfortunately, it's C, to forward data packets between different networks in routing from where they should go from A to B.
So close.
So close, one letter off. Let's go for the next one. What is the main difference between a local area network and a wide area network?
Main difference between a local area network and a wide area network. A local area network is limited by location. A wide area network would be used by for example, a wider spread business where they can connect multiple locations.
Yeah, perfect. 100%. So just a small network versus a large network. And the largest wide area network is in fact the internet. It is still a load of interconnected devices, so still technically a wide area network and probably the widest area network in the world. So true or false, a switch is used to connect devices within the same local network and can be used to connect networks together.
True.
So this one's true. Yes. Yeah. That's probably the hardest one. So let's take a look at the topologies. Now, topology is basically just a way of explaining how things are actually connected. If you were to draw them out in the real world, it's going to look like a whole mess of diagonal wires and squiggles everywhere. So we just simplify it down using a term called abstraction. And this can show us just what's going on theoretically. So a star topology, which is up here, it looks like a star. It's used in many large networks and small ones. So all the nodes are indirectly connected through the hub or the switch. So the printer here is connected to the workstation here. That's connected to this workstation. Everything is connected through the switch. So the pros is that each node is separately connected, and that means that they can't break if one of them breaks. For instance, let's say the workstation here broke. The workstation here is still going to be able to work, and so is the printer. The only issue would be is if the hub or the switch broke, and then, well, everything would break. So the cons of this is, as we can see through these arrows, there's a lot of wiring and also a lot of hardware, because we've got to purchase the hub or the switch and all of the wires that connect to it. But the pros are that it doesn't break quite as easily. And then we got the bus topology, which used to be very popular until people realized the main flaw of it. So the bus topology is super cheap, but one point of connection means complete unreliability, basically. If this wire gets severed, then nothing can run, because the data bus can't go down, it can't communicate, as the wire's just been broken. So even if there's like a small tear here, suddenly your whole network of all of these is reduced down to just a single workstation. So although it's cheap, it's also it's quite risky.
Are there any other benefits to this version?
So yeah, it's cheap. It's really easy to set up. I mean, for stuff that isn't particularly high sensitive, I know, for instance, LAN parties, if you've heard of those, which are like video games in just somebody's house, you could just connect that up using a bus topology. You're not going to need something like a star or even a ring here, because it's just a lot of money to set up. I know when people used to trade Pokemon on their DSs, they just use a single wire to trade and stuff. you don't need anything more than that. I mean, if it's really low, I suppose, security, then it's not really too much of an issue. So here we've got the ring topology, similar to the star in the fact that they're all connected indirectly. It's also quite cheap to set up, and there's not a single critical failure point like in the star. The only problem is it's a bit slower to get your data around. I mean, if you're here at the workstation, you need to access this server, you've got to go through the printer and the other one. Whereas in the star, you could have just gone straight across. So here we have the best one, which is the mesh, and it's fast. There's not a single critical point. Although with all of this crazy amount of wiring, it's confusing to set up, and it's also really expensive. However, if even like 2 or 3 of these wires break, you're still able to connect all the others. And even if every single wire here in the middle was broken, you'd still be left with a ring topology, which would work. So it's very, very reliable. However, it's also incredibly expensive.
So where would you most commonly see mesh topology?
Usually in business critical situations. So for instance, a trading floor, they're pretty likely to have mesh topology, and banks and stuff like that, where they really do not want to lose the information that they've got a hold of. Anything that is critical should be connected with the mesh topology, just to make sure it continues to run, even if something happens. Any questions, I suppose?
Absolutely, I do have a few questions.
Mm-hmm.
Why is it important for IT departments to monitor network activity?
It's really important for IT departments to monitor network activity for a multitude of reasons, of course, depending on the department that they belong to. So if you're part of a school and you monitor the network activity, you might see students cheating on exams. You might see them trying to look for the mark scheme before they've been released. You might see them searching stuff that's not school appropriate. This way you can crack down on that sort of behavior. Another really important thing for businesses that aren't schools are major businesses. For instance, if you work for Apple, Tim Cook, who's likely not the head of IT, but someone like that would be quite upset if they found you leaking the documents for the iPhone 17 to Samsung. So by checking the networks and seeing what people are downloading and from where, especially in secure file systems, you need a log of who's been on, who's downloaded iPhone 17.exe and sent it to Mr. Samsung. Yeah, it's good to check who's looking for these things, and that way you can keep a monitor on them and then potentially ban them if they're, I suppose, misbehaving very badly.
Yeah, keeps things secure. And what would happen to a business if its central router stopped working?
So for small scale businesses, if the central router stopped working, there would be no more communication with the internet whatsoever. Everybody would likely have to hotspot themselves, which is less intuitive due to the fact that you can't share printers and you can't share files as easily. It would just be a bit of a nightmare. However, for a lot of businesses that are of a medium to a large size, they're likely to have more than one router, just as a fail-safe in case something goes wrong. For instance, again, Apple would never have just a single router in their office. They've probably got multiple, especially banks or real-time applications, medical places as well. So hospitals are likely to have more than one router. Anything that they deem quote mission critical should have more than one internet access. But if a business were to lose its central router, then it would go through the chain and try and find a solution pretty quick to join to a different router that they've got available. And if there weren't any available, then that would be an oversight to put into the next findings of the audit report for what went wrong.
Fantastic. Thank you, Alex. Thank you for answering the questions. by the way, to anyone who's watching, please do feel free to ask your questions to us as well. We're always happy to answer them. If you want to send us an email or post a comment, we'll respond to it as well. But that's all the questions from me, Alex.
Yeah, perfect. Thank you for coming up with some great questions. And next time we are going to cover computational thinking. So
Wow.
looking forward to seeing you all then. Yeah, so goodbye from us and hope to see you next time.
Fantastic. Thanks, everyone. Bye-bye. Thank you, Alex.
Bye.